Every great business starts with an idea, but ideas don't build themselves. Introducing the new Fusion Ascent by Epilog Laser. An industrial-grade laser engineered not just for factories, but for the visionaries, the makers, the rising brands. Power, reliability, professional-grade results. Machinery that delivers without compromise. Powered by the unmatched performance of an Epilog laser. Because no matter how great your product is, your business can only move as fast as your most important tool. Featuring the new Fusion Iris HD Plus, turning placement into precision. Every detail exactly where you want it. You're building something extraordinary. You deserve an industrial laser. Discover what you can build with Epilog Laser's new Fusion Ascent.
Hey everyone, I'm James from Epilog Laser. Thanks for joining us today to learn about the new Fusion Ascent line from Epilog. I'm sitting down with two of our key engineers behind the Ascent to talk about the technology behind the system and why we're so excited about it. I'm joined by Chad Mitchiner, Director of Engineering, and Allen Blaylock, who's Director of Software Development. During the event, be sure to put your questions into the chat as well. Allen and Chad will both be here, and we'll be answering those questions throughout the discussion. Well, welcome to you both. Thanks for joining us.
Yeah, happy to be here. Thank you.
Yeah, same. Very excited.
Now, Epilog's been around for 35 plus years, and I know it has a history of a company being employees being around for a long time. I've been here for 25 years. I know you've both been with Epilog for a long time. Can you share how long you've been with Epilog and a little bit about what you do here?
Sure. This is Chad. So I have been with Epilog for 30 years this August. And I'm a mechanical engineer, and I run the sort of the product development side, do a lot of the design on the products.
Yeah, and I'm Allen Blaylock. So I've been here for, I think, 17 years. I started as an intern, so 4 of those years were as an intern. I'd come every summer. But since then, I have been leading the software group. I'm an electrical engineer by trade, so we make the circuit boards within my group, design all of that, basically from the circuit boards all the way to the web software that you could use in the form of Pulse. So, we sort of hit that whole gamut, which is pretty exciting and fun.
Nice. Chad, I feel like you and I, over those years, have gotten less and less hair, and Allen's maybe gotten more. I'm not quite sure.
Yeah, sadly, I think that's true. Yeah.
So let's jump into why people are here. They want to hear about the new Fusion Ascent. So it's available in 3 sizes, the 24 by 12, 24 by 24, and 36 by 24. It's a great variety of sizes for customers. So what goes into deciding what sizes of machines that we actually put together? Chad?
Yeah, so sure. So for the size of the machine, the 2412, 2424, and 3624 are kind of proven sizes for us. They're based essentially on standard workpiece sizes that are available in the industry. And then it's been successful for us in the past, so we didn't really see a need to change that. We'll probably get some chuckles when we call the 3624 a tabletop machine, but the feet are designed to sit on a standard 30-inch deep workbench. And then, of course, it's available with an optional pedestal as well, as are all these machines.
Yeah, that's a great point. So these are all desktop units at this point, right? Tabletop units.
Yes. Yep.
Nice. So let's talk a little bit about the laser sources. Allen, what laser sources are available in these systems?
Yeah, absolutely. So unlike our Pro lines, these have single sources. Because they're tabletop, we just don't have the space to fit them in, but we have CO2 and fiber sources. CO2 is a very versatile source. You can use it to cut a lot of materials, engrave a lot of materials. The fiber is more specialized in its use, so it's focused mostly on metal marking. You can do marking on other materials, but I would say that, that's really what our customers we see as their bread and butter. But, again, your material may be specific to one of the lasers, and so that's something, we'll always help you with as a customer.
What's the wattage kind of range that's available on these systems?
Also a great question. So on the CO2 based systems, we're going from 40 watts to 80 watts with our launch portfolio. And then our fiber will be 30 watts and I believe 60 watts.
Nice. That's a great variety available then. So everyone at Epilog always says that the laser is the heart of the system. Sorry, Alan, not just the software. Uh, Epilog's been manufacturing their own laser tubes for a long time. Now, what has Epilog learned over the years about CO2 lasers that really improves the performance of the Ascent, Chad?
Well, I mean, as James said, we have been building our own lasers for a long time. It's actually approaching 20 years. I have very fond memories of working on the first laser that we ever built and taking one of them over to one of our local suppliers at 4 in the morning so that they could weld it together for us. It was very exciting. But since we do design these lasers specifically for our market, we're able to fine tune them for laser engraving and cutting. That could be trying to achieve the best possible pulsing performance, short rise and fall times, so we get predictable performance, and we get the engraved images to show up exactly where we intend them to be. We know that some of these applications can be very demanding, particularly vector cutting. So we have designed our life tests to make sure that the lasers perform well in those applications. We do have a full team here that's dedicated to laser development and manufacturing. We have 7 engineers and 16 production employees. So that whole team, their sole focus is making the best possible lasers that they can.
Nice. You said short rise and fall time. What kind of difference does that make on the tube?
Yeah, so that means that from the time we tell the laser to go until the time it can actually produce a mark on the material, there's a delay. That delay is measured in microseconds, so it's not a long delay. But if we tell it to fire and then it takes a long time before it actually makes the mark, then the carriage is going to move a little bit and that mark is not going to be in the desired location. Of course, we can compensate for that, but it's much better if it just happens quickly to the point where the delay really isn't noticeable.
Okay. So are these easy to recharge and replace when there is an issue or when life runs out on it?
Yes, so we do. We have a gas lifetime target when we're designing of 7 years. When that is depleted, which can depend on usage and environment and some other factors, then it comes back to Epilog. We can change the gas, and then it goes through exactly the same final test procedure as a new laser. So once it's gone through that process, same technicians, same process, same test standards. Once it goes through that process, we essentially consider it to be as good as new.
Well, that's great. So customers don't have to wait if they do have an issue, they can get that next laser right away, huh?
Yes, it happens as quickly as we can. Of course, production considerations can sometimes make it not immediate. I want to just be clear on that, but yes, we do our best to get them back immediately. And it's very often not the same tube, but you can rest assured that that tube has been through our process and it is meeting all of our standards.
A very engineering answer, definitely not sales and marketing. That's great. So it's a metal ceramic design. Why does Epilog kind of go with that kind of design?
Yeah, so we have a ceramic and metal structure inside the laser, and then around that we chose to use a metal vacuum container or vessel. The reason for that is because the methods for joining metal to metal, welding, sometimes adhesive, all of those things are pretty well known in the industry and well established. Joining 2 pieces of ceramic together is tough, and the parts are expensive. So if that doesn't go as planned, it can be a very challenging thing for production.
I imagine that the fact that Epilog makes these in-house makes it very easy for us, comparatively at least, when there is a problem to get that fixed, since we're all taking care of that right here.
Yes, we have 2 or 3 engineers that are dedicated to production issues, and then everybody in engineering, whether it's on the machine side or on the laser side, production is their top priority. So if something goes wrong in production, they're going to try to get that solved as soon as possible. And, over 20 years, we gather a lot of data about, what makes a good laser and what potential pitfalls there are. So we sort of know what to look for, although we're not going to say we don't get surprised, maybe more often than we'd like.
So I know that many lasers have different amount of control actually at the display panel. I've seen some that just have a start button or Some have very simple controls, and Epilog's changed theirs a lot over this period of time. Allen, can you talk a little bit about the display panel on the Ascent and what you can do with that?
Absolutely, yeah. So I'm going to actually go all the way back to basically when I started. So when I started here, very shortly after starting here, we were working on the original Fusion. And at that time, the iPhone had just come out. So everybody was just so jazzed about, having this touchscreen device. You can flick things, you can move things. Basically, all of the things that you need are right there on the screen. And that was revolutionary at the time. And we were like, how can we get that on the laser? It took us a while. But that's essentially what we did is we're trying to get everything you need to be successful in using the laser right there on the touch screen. So your jobs, all of the settings that you need, being able to modify those settings, all of those kinds of things, at least for me, were a really powerful thing. Another one, back in the day, you would just have a line of text that said your job name. And so you'd print the same job again and again and again because you'd be modifying settings, which you can again do at the panel now. And you would just be like, which job am I even trying to run? They all look the same. And so now you can look at the jobs, you can look at the settings, you can see a little preview of what the job is going to be, all of those kinds of things. And that's been super helpful, at least for me using the laser. But I know that our customers have really enjoyed that too. So it just allows us to present a lot more information to the customer to help them in whatever process they're doing and also do more advanced processes.
And there's memory in the system as well, correct?
Yeah, absolutely. That's a great question. So one of the things that we've had for a long time, and we just sort of keep adding to, is the ability to save jobs in the system. So for some customers, they basically are trying to run, the same set of jobs again and again and again and again. And they don't want to have a PC nearby tethered to this machine. They want to just be able to turn on the machine and run jobs. And so the machine can remember the jobs, store them in it, and then each time you turn on and off the machine, you can have that same set of jobs show up and then run them. And so that's another really nice feature that we have in that.
Yeah, that's great. Calibrations are in there too, I assume?
Yeah, absolutely. So, it contains basically everything that you need to know. One of the nice things about the Ascent and some of our older products is they have some self-calibration routines. So, for example, the cameras are something that self-calibrate. Another one that I'm enjoy a lot is there's a calibration for the x-axis scale. So that used to be something that was difficult to do. You'd have to make a box that's exactly this big and then try to measure it as precisely as you can and then do some math. Well, now the machine just does that for you. And so that's a really exciting thing that we've added to the Ascent. And so, just adding little things like that wherever we can has always been, I think it's one of the most exciting things for my team is just how can we get the machine to perfectly calibrate itself on its own so that a customer doesn't have to do anything. And we're always thinking about ways to do that. And this is just another exciting time to be able to add at least one more of those types of things to the machine.
I assume that a lot of time this is also talking to our tech support team and what they're hearing from customers when you're trying to make these decisions.
Absolutely, yeah. So a big part of our software design is in feedback from customers. Service will get a call like, hey, a customer was having trouble doing this task or completing this thing. This workflow isn't quite as smooth as we'd like it to be, whatever it is of that sort. And then we can take that feedback and roll it right in. And so I also really enjoy that. One of the new features that we'll talk about in a little bit is part of one of those things where we got feedback and then it was okay, we know we have a good way to address that feedback and some fun things there. So yeah.
One of the big things that I've really noticed that I've enjoyed when playing with the beta machine that I was given to play around with and try out was the lens assembly. This has been completely redesigned, and I know that there was a lot of customer feedback that went into that design. Chad, you want to talk a little bit about that?
Sure, and that's great. And pretty proud of that part of the design, and we'd put a lot of time into that part of the machine. But yeah, so based on some of the customer feedback and other internal feedback that we received, we felt like we had to make the lenses easier to clean. So they are very easy to remove now. There's a front plate on the carriage that's held on with magnets, so you can pull that off. And then the lenses pull out, and you can get a very good look at both sides of the lenses in your hand, and they're very easy to clean. They're color coded for which shelf inside the system they're supposed to go on. So there's, for example, a blue shelf in the middle, which corresponds to our 2-inch CO2 lens. And then above that, there's a yellow shelf, which goes with our 3-inch fiber lens. And then some of our accessory lenses go on the silver shelf at the bottom. But regardless, you cannot put them into the wrong location. They're pinned and keyed, and they can't be put in upside down either. And then it should be easy to change. Everybody knows that it's important to keep the optics clean. So we feel like it's our responsibility to do as much as we can to make that as easy as possible. So that is one of the things that, we're really excited about as well.
So is there any change to the airflow within that lens carriage as well for keeping debris off of those mirrors?
It's similar to what we've done on previous machines. However, it's separated from the lens. So there's a breakaway air assist cone assembly that attaches to the bottom of the carriage that has kind of a dual air assist cone. So the air comes in, it's directed down away from the lenses, but then contained by an outer cone to provide that kind of cone of air that we need at the engraving point to, do what the air assist is supposed to do.
Nice. Now, one of the things Epilog's really known for is speed and precision. You can see that in our famous Aztec calendar. If you got into a trade show, I'm sure you've picked one up over the years. Fusion Ascent runs at a top speed of over 3,000 millimeters per second or 120 inches per second. Now, that's a big increase from the Fusion Maker, which is our previous entry-level laser. What's some of the engineering that's gone into creating that high speed of engraving for the Fusion Ascent, Allen?
Yeah, that's a great question. That was actually like a big challenge in this engineering cycle, was hitting those speeds. Obviously, we've done it on our Fusion Edge and our Fusion Pro, but we wanted to deliver that kind of performance at a cost that everybody can access instead of just having it be the absolute premium tier. And so figuring out a solution to that, and what we ended up on was servo systems. There were some additional challenges posed there, namely getting that raster data, so the engraving data out onto it. So we introduced a linear encoder as part of that. So that was another sort of key thing. But really hitting those top speeds with high accelerations is, it was a really big challenge. We went around and around and around with a bunch of different topologies to try to sort of get that at the quality, standards that we sort of internally adhere to. So lots went into that.
Nice. So what is kind of acceleration, or what are we talking about when you're saying acceleration, when you're talking about a laser?
Sure, yeah. So the acceleration is sort of how fast we can get up to speed. And then there's the top speed, which, everybody understands going 60 miles an hour versus 30 miles an hour, but it's more like the quarter mile time if we were racing a car. So it's like how fast, a lot of that time is spent speeding up to get to the 60 miles an hour, 100 miles an hour. So it's your 0 to 60 equivalent in cars. We use a 3G average, 5G peak acceleration profile. And that just means that you're going to spend more time engraving at that top speed. So you're going to have a higher throughput.
What kind of goes into something that I noticed on some machines is you get kind of a pause at either end of a line. What kind of goes into that turnaround time?
Yeah, so basically you want to spend as little time stopped as possible. So, when you do the math, it turns out that you're going to spend almost all of your time at these slower speeds or stopped, as opposed to these top speeds, because, you're going fast, you're covering a lot of distance, while the thing's only so wide. And so, as you said, we don't want to spend any time at the end if possible. And so what we do is, as we're doing our raster scans or our engraving scans, we'll actually finish clocking out the data, and then we'll blend down into the next location that we're supposed to be, and then pick up immediately and start going the other way. So, if you look at a graph of our acceleration. It's basically accelerating constantly in the direction, when you're slowing down, you're accelerating this way. And then when you're speeding up the other way, you're still accelerating this way. And so we're just doing that as hard as we can to go back in the other direction to get that next line out.
You mentioned linear encoder as part of that. Chad, that's something we've used on previous systems, I know, but is being brought back. How is this different, and how does it make the speed and precision better in the engraving?
Yeah, so the use of linear encoder, essentially what it does is it's a position sensor that is tied directly to the carriage. So there's no disconnect created by the belt, which is essentially a spring between the motor and the carriage location. Our previous system used an optical linear encoder, so they were susceptible to dirt and sometimes wear if they were adjusted slightly wrong. But this is a magnetic encoder, so it's very resistant to contamination. The worst thing that could happen there is if we actually let like a millimeter of debris build up on it, then it could potentially crash with the sensor, but that seems very unlikely, and it's very easily accessed from the front of the X-rail. It just needs to be wiped down periodically, just like you would do maintenance on the machine normally. It is a very high resolution encoder, which is great for our engraving quality. It's a 1 micron encoder versus our old encoders were 1200 DPI. So I think that works out to, about a half a thousandth, but a lot more than 1 micron. So what this allows us to do as far as the engraving quality goes is we know essentially exactly where the carriage is at any given time, and we fire the laser based on that position, and we get very good accuracy of where those pulses are, combined with the fast laser reaction time, rise fall time that we talked about earlier. The engraving quality is quite good. We're very excited about that part.
So is that the only encoder basically on the system that's telling the laser where it is, or is there other ones too?
No, there's also an encoder on the back of the motor, on the X motors. So that controls all of the motion. And then the linear encoder only tells the laser where to fire in raster mode. In vector mode, we work entirely off of the rotary encoder. It's on the motor.
Okay, great. Now, one thing I've noticed recently is that some machines that are out there kind of have a top speed that sounds pretty impressive, but can only be used on part of the table. Is that true on the Ascent?
No. So one of the great things, both about the linear encoder and then just generally about our machines, is you can engrave across the entire stroke of the machine when you set the machine to run at the top speed. So, we don't sacrifice any of our engraving area for for getting up to speed or anything like that. And part of that, as we're mentioning, is due to the linear encoder. There are tricks that you can play to sort of get around that, but at the end of the day, measuring the thing you want to know directly, where is the carriage, where is it going to fire, is the best way that you can possibly do this. And so that allows us to get really good engraving quality across the table and for the full table.
What are you kind of adjusting when you're actually trying to get that same engraving quality across the table to the same depth, even though the speed is changing?
Sure. So there's like a lot, as you can imagine, that goes into that. The primary thing would be sort of how much power you deposit in a given area per unit time. So that means that we have to take into account some of the speed, we have to take into account some of the actual laser performance, and all of those things are things that we consider when trying to get that really uniform mark across the entire bed.
Nice. Look, now let's talk a little bit about the cameras. I've
Sure.
always been impressed with how accurate the overhead cameras are. Fusion Ascent has one overhead camera, and I believe the Ascent 24 and 36 both have two. What engineering and software kind of goes into having precise positioning with these overhead cameras?
Yeah. So this is one of my favorite things to talk about, especially like when I've led tours here at the factory. We have spent an enormous amount of effort getting a really, really high precision calibration. So in the world, so cameras in the sort of world of engineering, we talk about it in the terms of like computer vision. And so our computer vision algorithms and calibrations, et cetera, are a little bit at odds with what you typically see with like cars or something like that. We're trying to measure things on the order of thousands, not on the order of centimeters or inches. We're like looking at really small areas instead of big areas. And so getting that really, really high accuracy calibration is difficult, and we spend a lot of time on it. So the first step in that is specifying custom cameras. So all of the cameras that we use in our systems today were specified by us. We work with a camera manufacturer, but we say, we want this exact detail. We evaluate an enormous number of lenses, go back to the lens manufacturer, say, hey, can we make these modifications? Those kinds of things. So it sort of starts right at the hardware, and then it builds from there. The next step being calibration. So that is a huge effort that we put forth here as we calibrate each individual camera themselves here. So the cameras themselves have a calibration, and then the next step is calibrating that camera to the machine. So that's one of the big differences, I would say, between us and other folks is we calibrate the cameras where each camera is very specifically and in a very sort of sterile environment calibrated. Most camera systems that we've at least observed in our competition just try to do everything in the machine. And for various reasons, we don't believe that is, really gives you the quality and the precision that we need. So that's a step that's sort of missing. And then there's the in-machine calibration step where we actually say, okay, where is 1-1? There's some location on the bed that's corresponding to 1 inch off by 1 inch off. Where's that? Where's, the other end of the bed? How do the two cameras, if it's a multi-camera overhead view, how do those sort of stitch together in a line? And so we have some fairly sophisticated ways of calibrating that as well. And so we sort of, through that entire pipeline, work to drive sort of our error, our calibration error to zero. And then, of course, there's some things where it's like there's resolution dependence, or you're dependent ultimately on the resolution of the camera. And that's actually an interesting thing. Lots of people talk about megapixels, more megapixels, more megapixels, more megapixels. That actually doesn't buy you a whole lot, because the area, if you double the area, or you increase the side length by a factor of 2, like you need to go up by a factor of 4 in the sort of resolution to maintain the same amount of resolution, like how large a pixel is mapped to the bed of the machine. So that's a pretty diminishing return thing. Instead, and I don't know if we're ready to talk about it, but instead we've moved on to a new feature that we're really excited about, which is HD+. And that allows us to use the head camera to get extremely high resolution images and extreme calibrate or precision location of engraving results. So you can use the overhead view to get pretty accurate things across the bed. But if you're like, hey, I need to nail this, whatever the feature you're trying to engrave is, we now have a feature called Iris HD+, which allows you to just zoom in with absolute precision on given locations, and you can get that around across the entire bed to really nail whatever it is you're trying to align, or whatever. And that's going to beat a higher resolution sensor any day of the week, because you're mapping a small area onto the entire sensor. So that's something that I'm really excited about getting out there for folks to use. But we love it internally. It's been super useful for a lot of projects that we've done.
Yeah, I've really enjoyed testing that, I have to say, Alan. It's been a lot of fun. One of the things that I find really useful is when I've got a tall item in the machine, because that always kind of throws off just the visual balance when you're trying to line something up. Being able to go to the top corner of that and say, this is my top corner, fantastic. Just really a game changer for me.
Awesome.
That registration camera is also obviously for print cut, correct?
Yeah. So that's a feature that we've brought to the Ascent. So the ability to sort of add fiducial marks, or at least that's what we call them, little black dots, are what we use as our fiducial to the original piece that you're trying to cut. And then that allows us to align the artwork sort of perfectly with that, and then cut out or engrave the pattern onto your material. So the commonplace, as you said, that we see this is in printing. So, people will print out designs on acrylic or on paper, and they'll want to cut them out. And so that was a feature that long ago we sort of introduced on, I think, our Fusion M2, but we've continued to bring those really professional level features, to everybody. And I think that that's a really important thing. That's a big part of what this machine is for, is to, make sort of the best accessible to everybody.
And is that feature available for people that have registration cameras in the Fusion Pro?
Absolutely, yeah. So one of the things that we always try to do is, wherever possible, make new features available to old systems. So, we're always bringing and updating things. And, I think I'm trying to remember what year we launched the Fusion Pro, but it still gets the same firmware basically that the Ascent does. So that's quite a long software lifetime of that product. It's still getting updates, and we're going to continue to update it in tandem with the Ascent.
Nice. So, Chad, it's been a while since we heard from you.
Yeah,
let's
still
talk
here.
about let's talk about the build quality of the Fusion Ascent. The chassis is made of aluminum, correct?
That's correct. Yeah, it's an evolution of the Edge and Maker. It's going to seem very similar in a lot of cases. It is riveted together. And what we love about that process is that it's like a QA test for every part. There's only a few thousandths of clearance on each rivet hole. So if somebody doesn't form a part correctly and something doesn't line up, we can get that part out of the process prior to, forcing it in or having, somebody put in a part that doesn't meet our standards. And we prefer riveting over welding, simply because when you weld something, you add a lot of heat to the part. And the result of that is typically that the structure will warp or bend. That can be corrected, but it's a very challenging process. And we found that riveting is more than strong enough for our application, and, has other benefits we talked about previously.
And that doesn't weaken over time of use of the machine then?
No, it doesn't. We haven't found that to be the case.
That's great. So also I imagine, go ahead.
I was just say one feature of the chassis assembly that I think James was trying to lead me to earlier, and I went down the wrong road. But in addition to the air assist flow that we talked about, we've also done some significant changes to the exhaust flow. So we had, all the observations, and we've heard that, smoke swirls in the back, or we have other issues like that, and that can tend to, contaminate lenses. It can just get the debris all over the machine, or just be unpleasant because there's smoke that remains inside the machine. So, we went through all the usual simulations and tried to map the airflow, but then ultimately we had an intern last summer, and we just had him build a new airflow mechanism on the laser. And it was really cool. It worked great. And the only downside was that he was picking super glue off his hands for the next 2 to 3 weeks, but he did a good job for us.
Nice. So you're not using super glue at this point?
No, only rivets.
Okay, okay, that's good. All right. So since you're using the type of chassis design you use, it's pretty easy to get to all the parts, I assume. So someone can fix anything they want to on the machine?
Sure. Yeah. I mean, there's enough screws that have to be removed, but all of the major components are accessible, whether it's the entire X-rail, or if it's a power supply module, a laser module. We talked earlier about the laser being easy to replace. It is 3 screws that hold the laser in place, 3 captive fasteners. So you don't drop the screws when you take the laser out, and then you can put the laser back in. We do our best to make them aligned, consistently, but there will most likely be some adjustments necessary, some minor adjustments to the alignment if you replace a laser.
Now, one of the features that I know people have been asking for a long time, that's going to be on this machine now, is pass-through. You can do large items front to back. Can you tell me a little bit about that, Chad? And why has it taken Epilog so long to come up with pass-through?
Yeah, we just, we have fundamental concerns here at Epilog about safety, and safety for our customers and our internal employees is our number one concern. So when we, I guess, finally admitted that the market is demanding that we have pass-through on our machines, then we took it upon ourselves, and it was, me and Allen and our compliance person and others to really try to figure out how to do it correctly. And where we landed was that we have a Class 4 conversion kit, which, includes what we call a dongle, but you might consider it like a key or something that goes in the side of the machine. And that enables the Class 4 mode. And more importantly, that kit includes training. So that kit includes training to basically give the customer the opportunity to have a laser safety officer on their staff. That was a big deal for us. We partnered with Kentech, who is a well-known laser safety company in the industry, and they prepared videos and training for us. It was back and forth while we gave them some advice on what we wanted to do, and of course they gave us some advice on how to make it as safe as possible. And yeah, we landed in a good place. We're very excited about this feature. The max material height is 2 inches, and then you can have a piece go in that's the full width of the machine, whether that's 24 inches on a 2412 or 2424 or 36 on a 3624.
Nice. So, Alan, what were some of kind of the problems or market needs that Epilog was trying to solve with the development of the Fusion Ascent?
Sure. Yeah. I think that we just talked about one, people are interested in being able to operate their systems in sort of a pass-through or Class 4 mode. And again, just to hit on that one more time, safety was our big thing there. I just don't think that, when I do market research, people are really focused on making sure that it's safe. They'll make claims and whatever, but I personally tried to go the extra mile, and I know that everybody here did, to make that something that our customers can really sort of rely on, that they're going to have what they need to be safe, and that, we're not going to sugarcoat it. We're going to tell you, this is a dangerous thing. You can operate it safely if you follow these procedures. But, that was a big thing, for example. Another big thing that we added to this, sort of from the market was, we want to bring sort of the highest performance machine to all of our customers that we can. Obviously we still will have our Pro line that will be higher performance. At some point there are more dollars that need to be spent to get better motors and bigger lasers and whatever. I mean, that's just, there's simple economics involved there. But the best that we can do for the money. And so that's something that we really focused on with this effort was, what's the best that we can deliver to our customers so that they're getting an enormous value and something that they can really rely on and build a business out of. And I think that's something we've always tried to do, but that was something where we just really focused in on it and said, okay, our customers rely on us. They've maybe had a hobby laser and now they're ready to make a business out of this and turn it into something real. Not to say that it wasn't real before, but really scale. And have something that they can rely on. And I think that that's something that we continue to focus on, but really was a highlight of this system. Nice. So I think that that's a big area. And then, of course, quality is something that we also focus on throughout that. I've talked about relying on it. How do we do that? We produce a quality product. I'm trying to think about how, if I have a fun anecdote there, but I think the biggest thing would just be, we test components in these machines. We abuse them basically, so that when our customer gets it, sort of the worst that the customer can throw at the machine, we've already done worse. And that's really a big thing. We take the motors, we run them until we find them dead. And it's like, is this long enough? If yes, then okay, we can ship it. If no, we need to figure something else out. We run it in the machine. How does the debris build up? Is that causing issues? Okay, that's a problem. All of those kinds of things. We're always looking at the kinds of issues that our customers face, and making it so that the machine will just keep running and be able to produce high quality results, through its entire lifetime.
Yeah, we took a similar approach on the laser as well. We may have touched on this earlier, but we have a very challenging life test that we put all the lasers through, and they have to pass that test for a minimum of 2,000 hours before we'll commit to a design and say it's ready for production. And 2,000 hours might not sound like a lot, but it's, like I said, it's an extremely hard test, and it has scaled well to, to a reasonable lifetime if we can pass those tests. And we don't stop after 2,000 hours either. We've got some back there that are at 6, 7, 8,000 hours.
That's great. So what category would you put this laser in, Alan? Do you call it entry level? Is it for production?
Sure, yeah. I think that calling it entry level isn't quite right. I think that for us, it's something that anybody can access. We want it to be for people that are just starting out, but we also want it to be for people that are, doing more professional work. So, again, it's sort of accessible, but it's also got the quality of, a true industrial professional laser system. And I would have absolutely no hesitation to just say, this is the machine that you need to buy if, you're either just starting and trying to start this business where you're going to be engraving and cutting a lot, or if you've got an established business and you're looking for like, okay, I either need to replace machines or I need new machines to expand capacity or whatever. It really is, I think, an enormous value.
That's great. One of the things I always hear at trade shows is when I'm talking to people that have purchased other lasers is, I wanted the Epilog. So, I think this is a great way to get into that crowd and let them see that, the throughput does pay for itself with a lot of these businesses, I think.
Absolutely.
So let's talk a little bit about kind of the planning that goes into a machine like this. What kind of cross-team collaboration with an Epilog kind of influences that final product?
Yeah, so we
Go ahead.
probably started on this project. It's been a couple years at least now, but we have weekly meetings with sales and marketing, engineering, some other management folks, and we really just talk about what we think the market needs. From there, we might go into some like proof of concept designs and things like that, but we're always coming back to, is this machine meeting what we think the market needs? And that can evolve too. I mean, it's not like we always go down the right road from day one. We may have to shift gears or change paths midway down the road. And we just have to accept that as engineers. We can't just build what we want to build. We have to make sure that the market wants what we've done. And I think this is going to be a good one.
Yeah. And I think that the other thing that it really buys us is it buys us a lot more like integration. So as I'm designing the software, Chad's designing the hardware, and at some point we have to meet in the middle, right? Like we can't just build each in isolation. That doesn't work. This allows us to really tightly integrate our systems. So for example, the camera system isn't a USB camera that you plug into your computer. It's integrated into the machine, and that gives us benefits and gives us, really you, the customer, benefits for the use of the machine. And that sort of just shows up time and again across the machine, where it's just like we sort of own that process end to end. If I have an issue, I can go up to Chad and say, hey, like, I don't think I'm going to be able to solve this in software. Is there a way to solve this in hardware, and vice versa? We can really come up with clever solutions that I think other manufacturers, where they're integrating just components, aren't able to do. And again, the same with the laser. That's another area where, it's like, hey, we're trying to get the absolute performance, maximum performance out of this thing. What can you do to help us? And that would be a question we'd go to our laser team with.
Nice. Now, I know we're all proud that Epilog's global headquarters is here in Golden, Colorado. I know I'm very proud of that and very happy because I found Epilog 25 years ago. I remember coming into my first interview and Mike Dean, Mr. Epilog, showed me the laser, the first thing, and I was blown away because my mind just exploded with everything you could do with it. But it's great to see the company thriving after so many years while building machines from the global headquarters. Can you tell us a little bit about how much of this machine is actually manufactured in Golden?
Yeah, so interestingly, I also interviewed with Mike on my first day, and he was walking around the factory with no shoes and a towel thrown over his shoulder. I think he was just back from a bike ride or something. So
How
I
many
knew I'd
employees
found
were
my home. I knew
how
I'd
many
found my home at
employees?
that point.
Yeah, how many employees were there then, Chad?
17. I was number 17. Yeah.
Nice.
So yeah, we are excited about being in Golden, and we're excited about building a lot of the product here. Everything is assembled here in Golden. We have a production team of about 20 people. And then I have support engineers on my team that work to support production, as do all of us, whenever it's necessary. We have great relationships with local suppliers. I mean, we've been with them so long that we've seen kids grow up, and we've seen kids take over for their parents and keep those those businesses in their family. Um, it's been a remarkable ride in that sense. It's so many great relationships that I enjoy, and we've got 3 really high quality machine shops that we work with here locally, 3 very high quality sheet metal shops. Um, yeah, and I mean, we'll call and ask for favors, and we can pretty normally get what we need to get out of them. I mean, and it goes both ways. We treat them with a lot of respect, and they do a great job for us in return. Undoubtedly, every machine at this point is going to have some parts from China. I mean, that's the way the industry goes. Motors, PCBs, those kind of things, they're kind of dominate that industry. But we do try to keep, particularly stuff where we may need to go over and try to solve a problem with them. It's not unusual at all for us to hop in the car and drive over to the sheet metal shop and, brainstorm with them about how to solve an issue. And, we know all those people, whether it's the president of the company or the person on the floor. We walk through their offices and everybody will be like, "Hey, how are the kids?" Whatever, and it's been really good to have those relationships.
Alan, and can you want to talk a little bit about how support is handled as well with this machine?
How support is handled? Sure. So Epilog staff's support here out of Golden. We have a European office as well that provides support for our European, market. And basically what we do is we have technicians that have, I think some of them have decades of experience with our machines. I believe we have a 2-year warranty on our systems. It's sort of all of the, whatever goes wrong, basically, we're here to help. I have seen software tickets come in that are completely unrelated to our machines. It's like, how do I get my Wi-Fi set up? Or, something to do with like designing your artwork. We've got the material support. I'm part of one of our internal chats that's like, hey, a customer is having this issue with a material. Have you guys seen this? What might we try to get that material to engrave in the way that they want? And so, we're always providing support. And I think that, again, that sort of goes back to the quality that we talked about earlier, where it's you're depending on us in some part for your laser business, and we are going to be providing, whatever we can to sell to help you be successful. And that means that we have to have a lot of knowledge internally, both about how our machines work, how to service them, and how even beyond that, how you use them. And so I'd say that that's just something that at least I find a huge value in. You can get answers from us on a huge number of topics, and we try to give you really high quality answers.
That's great.
Yeah, and we've been working through the Ascent training with the service team here over the last couple of weeks, and it's been really interesting to see the kind of things that they point out that maybe, we hadn't thought about completely, and then we can show them how we were thinking about solving that problem. And it's been a very interesting process, and I think we're going to be very well prepared to get this machine out into the market.
So to finish up, what does this system kind of represent for the future of Epilog Laser's technology and the company? Alan?
Sure. I think that, the market's changing. More and more laser machines are coming out. And, we really want to place ourselves at a location where, we are producing extremely high value. That doesn't necessarily mean that we're the cheapest, but it does mean that we're going to sort of be something that you can rely on to get return on investment. You know, you're going to invest in this thing and it's going to sort of stand by you and provide excellence through its lifetime, for you and your business, you know, whatever it is. Or if you're a school and you're engraving, you know, you've got a bunch of kids coming through that are cutting out projects. You know, we need these systems. People rely on them to be able to accomplish whatever they're trying to accomplish. And we just want this to be, you know, sort of a continuation of that, but also recognizing that, you know, it is really competitive, and this is a machine that sort of helps address that. It really focuses in on bringing value to you, the customer, while bringing all of the additional things, the quality, the reliability, etc., of a historical Epilog machine.
That's great, guys. You know, I really want to thank you both for sitting down with me today. I think this was a lot of great information. And for everyone out there that's watching, if you go to epiloglaser.com, you can find the entire Fusion Ascent line now up there. Fill out that form on the website, and we'll help you set up a hands-on demo on it as well, so you can see which machine's right for you. We'll stick around for a few minutes and answer more questions in the chat, but if you guys appreciated this and found this helpful, be sure to leave a comment, and we'll see you again soon. Thanks, guys.
Thank you.
Thank you. Bye.